Hello students, welcome to another class of measurement and control. Today we are going to study about flow measurement. We are going to follow the syllabus prescribed by West Bengal State Council of Technical Education and Vocational Training. The first topic is rotameter. A rotameter is a constant pressure drop variable area flow meter. It consists of a vertically placed tapered tube with a float within it which is free to move within the tube. A rotameter is shown in the figure, which is made up of glass. The material of the tube is made up of glass. The fluid flows through the tube from bottom to the top. When no fluid is flowing, the float rests at the bottom of the tube. The float is made of such a diameter that it completely blocks the inlet, that is the small end of the tube. When a flow starts in the pipeline and the fluid reaches the float, the buoyant effect of the fluid makes the float lighter. Usually the float has a density greater than that of the flowing material, so that the buoyant effect alone is not sufficient to lift the float. The float passage remains closed until the pressure of the flowing material plus the fluid buoyancy effect exceeds the downward pressure due to the weight of the float. The float then rises and floats within the flowing medium in proportion to the flow at the given pressure. As the float moves upward towards the larger end or the outlet of the tapered tube, an annular passage is opened between the inner wall of the tube and the periphery of the float. This forms a concentric opening through which the flowing material passes. The float continues to rise until the annular passage is larger enough to pass all the material coming through the pipe. The fluid or gas velocity pressure falls until this plus the fluid or the gas buoyant effect exactly equals the weight of the float. The float then comes to a dynamic equilibrium. Additional increase in flow rate causes the float to rise higher in the tube. The decrease in flow rate causes the float to sink to a lower level. This means that every float position corresponds to one particular flow rate. The float gives a reading on a calibrated scale etched on the glass tube, and the flow rate can be determined by directly observing the metering float. The next topic of flow measurement is electromagnetic flow meter. It consists basically a pair of insulated electrodes buried in the opposite sides of a non-conducting non-magnetic pipe carrying the fluid to be measured. The pipe is surrounded by an electromagnet which produces a magnetic field. The arrangement is analogous to a conductor moving across a magnetic field. Therefore, a voltage is induced across the electrodes. This voltage is given by E equals to BLV, where B is the flux density, L is the length of the conductor, which is equivalent to the diameter of the pipe in this case, and V is the average velocity of conductor, which is the fluid itself in this case. Thus, assuming a constant magnetic field, the magnitude of the voltage appearing across the electrodes will be directly proportional to the product of average velocity and diameter, and therefore in fact this meter is a volume flow rate meter. The non-conducting pipe has to be used as the output voltage gets short-circuited if metallic pipes are used. This is true when liquids of low conductivity are being measured, but when liquids of high conductivity are measured, the short-circuiting has no effect. Stainless steel pipes can be used in those cases. We do have many advantages and disadvantages of electromagnetic flow meter. Few of the advantages are: number one, they do not produce any obstruction to flow and hence cause no pressure drop. Number two, the voltage output of these meters is proportional to average velocity and hence it does not matter whether the flow is laminar or turbulent. Number three, the measurement is also independent of viscosity, density, pressure and temperature. Few of the disadvantages are: number one, conductivity of fluids must be higher than a certain minimum required level. Number two, the meter must be full at all times because it sees velocity as analogous to volume flow rate. Now, the next instrument in flow measurement is anemometer. Anemometer is a device which measures wind speed. It is a very common instrument found in weather stations. Anemometer can be divided into two classes, one which measures wind speed and another one which measures wind pressure. Another type of anemometer is hot wire anemometer. A hot wire anemometer is defined as those anemometer which has a hot wire resistant transducer and are used for measurement of flow rate of fluids. Flow rate of non-conducting liquids in open channels and closed pipes and of gases in closed pipes can be measured very conveniently by suitably locating this transducer, which is in the form of a wire element. The wire filament is usually a fine wire of platinum or tungsten and is mounted in the flow channel by means of a support. The diameter and the length of the wire depends upon the size of the pipe and the maximum flow rate which has to be measured. The diameter of the wire varies from 5 micrometer to 300 micrometer and length is approximately equal to half the diameter of pipe. The probe is located at the center of the pipe with direction of wire perpendicular to the direction of fluid flow. The hot wire technique of measuring flow velocities has assumed great significance as the measurement can be done without disturbing the existing conditions. The method can be used for measurement of low velocities. The hot wire probe can be placed in a small size pipes without causing any pressure drop in the fluid stream. However, it can measure only the average velocity of flow. The method is unsuitable for velocity measurement if the fluid is conducting in nature. The main application of hot wire anemometers are for gas flow and wind velocity measurement and in laboratory for flow measurement of non-conducting liquids and gases. Hot wire anemometer are classified or commonly used in two different modes: constant current type and constant temperature type. In constant current mode, the fine resistant wire carrying a fixed current is exposed to flow velocity. The flow of current through the wire generates heat on account of I2R losses. This heat is dissipated from the surface of the wire by convection to the surrounding. The loss of heat due to conduction and radiation is taken to be negligible. The wire attains equilibrium temperature when the heat generated due to I2R losses is equal to the heat dissipated due to convective losses. The circuit is so designed that I square R heat is essentially constant, and therefore the wire temperature must adjust itself to change the convective loss until equilibrium is reached. The resistance of the wire depends upon the temperature, and the temperature depends the rate of flow. Temperature depends on the rate of flow. Therefore, the resistance of wire becomes a measure of the flow rate. In constant temperature mode, the current through the wire is adjusted to keep the wire temperature as measured by its resistance, which is constant. Therefore, the current required to maintain the resistance and hence temperature constant becomes a measure of flow velocity. The next flow measurement meter or flow measurement device is ultrasonic flow meter. Now, in the previous topic, we have found out that we are using electromagnetic waves, and also we have used resistive type of wire for measuring the flow. Now we are going to use ultrasonic sound to measure the flow of fluid within a channel or a pipe, obviously. Now, the operating principle of this type of instrument is based on the apparent change in the velocity of propagation of small magnitude pulses which travels through a fluid at a definite velocity, normally at a velocity of sound relative to the fluid. If the fluid itself has a velocity, then the absolute velocity of pressure disturbance propagation is the algebraic sum of the two. Since the flow rate is related to the flow velocity, the effect may be used in several ways as the operating principle of a ultrasonic flow meter. The term ultrasonic refers to the fact that in practice the pressure disturbances are usually short bursts of sine waves whose frequency is above the range of audible range to human beings, say 20 kilohertz. A typical frequency may be 1 megahertz. The method uses transmitters and receivers, or in a word, transreceivers of acoustic energy. Piezoelectric crystals are used as both transmitter and receiver. In a transmitter, electric energy in the form of short burst of high frequency voltage is applied to a crystal, causing it to vibrate. If the crystal is in contact with the fluid, the vibration will be communicated to the fluid and propagated through it. The receiver crystal is exposed to these pressure fluctuations and respond by vibrating. The vibration motion produces an electric signal in propagation according to the action of piezoelectric displacement transducer. The transmitter emits an ultrasonic pulse which is received at the receiver at a delta t time later. Now, this particular topic concludes the flow measurement that we have within our syllabus prescribed by West Bengal State Council for Technical Education and Vocational Training. And I thank you all for your kind attention. Thanks a lot.